as young practitioners intend to use this opportunity to get knowledgeable resource persons from around the world in order to become conversant with the latest digital technologies being used all around the world. Um, we actually started this young practitioners webinar last year, April, and we've had people come from South Africa, um, guest speakers from South Africa, from New Zealand, from the UK, from the UK, from New Zealand, from South Africa, and today's guest is reaching us from Chile. So thank you once again. Um, Going forward, I would like to invite Engineer Huda to read the mission of the young practitioners in construction. Hello, Ms.
Welcome,
Huda.
everybody. Hello, how are you? Can you
I'm
hear me?
fine. Please go
Can
ahead.
you
We
hear?
can hear you.
All right. Welcome, everybody. I would like to welcome you for our monthly sessions. And thank you, Prof. Matthias. Our mission is empowering young practitioners through strategic partnership and organizing programs in the built environment. This is what we would like to do through this year again, inshallah. Thank you very much.
Thank you so much, Engineer Huda, for that presentation. We move over to the reading of the citation of our guest speaker. And so we'd like to invite Engineer Julius to please present the citation of the guest speaker.
Good evening, everyone. Thank you, Mr. Moderator, for this opportunity to read our guest speaker's citation. I'm just quickly going to share the PPA so that everyone can actually follow. Okay. Our guest speakers today is our Professor Matthias Valenzuela. He is a professor and head of the Civil Engineering and Construction program at Pontificia Universidad Católica de Valparaíso in Chile. He is a senior bridge engineer, specialist for bridge asset management at Equibridges Limited. He is also the vice president, International Association of Bridge and Structural Engineers, IABSE. Professor Mattia has served as an advisor for structures and technical officer and structural engineer from 2007 to 2024 at Ministerio de Obras Públicas Dirección de Vialidad in Chile. I'm sorry if I didn't get the right pronunciation very well, but yeah, so I think our guest speaker will have the floor now. Thank you so much, Prof. Okay, let me unshare.
Okay, thank you so much, Engineer Julius, for that. So we now, please, Engineer Julius, unshare so that Prof can take over. Okay, So we'll now invite Prof. Matthias to please take the floor.
Okay, thank you very much, and good evening, good afternoon from my side. Thank you very much for this kind invitation, and of course, the opportunity to share what we are doing here in South America, in Chile, and overseas even with different entities. So let me share my screen, and I will try to move with my presentation. 1 second, please. Can you hear me well? Yes, right?
Yes, Prof, we can hear you.
Okay, thank you very much. So I know that I have 40 minutes to talk about of something that we are doing in digitalization in construction and operation, and I will try to focus in transport infrastructure, but I'm also talking about of buildings as a case of studies. So I will try to move a little bit fast in order to show you as much I can. Okay, so if we have time later for more questions. So, as Julius said, I'm professor in the Pontificia Universidad Católica de Valparaíso. Excellent Spanish. Thank you very much. Very well pronunciation of that. And here I want to acknowledge my entities that support this presentation. First, the Catholic University of Chile, Equibridges. It's a company in Switzerland, and now we are also here in Chile. And IAPSE is International Association of Bridge and Structural Engineer that working about of digitalization in several task groups. So thank you all for all of them, and of course I encourage you that you can see what is happening in all of these entities. So let me start with the development of the what means the digitalization in Chile. And the first thing that I can talk about is about of BIM, Building Information Modeling. And why that? Because, of course, building information modeling is a methodology for collaboration between different stakeholders in the construction, during design, and of course in operation. But also you have different software and different technology that you can implement it in order to improve the BIM methodology. Well, in 1975, it started with the public of BIM. Then we moved to the ISO step that regulated all the model. In the 1994, I'm talking about in all around the world, started with the IFC development, and the 2000 we started with Revit, and then moved for the first experience in Europe, for example, the case of Finland, and in 2007, US also be part of that. So what is the important thing here is that we are moving in several ways that the collaboration is something that it's important. And you can see that in 2018, a mandatory use of BIM, for example, in Spain for the public tenders, provide a specific way that you have to be collaborative during construction, be collaborative during design, and also push a little bit the technology. Something happened in that in 2016 in Latin America, because that years we started with the implementation of BIM in several ways. So let me now move for this map, and you can see here I'm talking about of South America, and you can see here in South America that we have frequent use of BIM. In the case of Chile, that long, narrow country, my home, Peru in the north, and Brazil. But also it's preliminary or the first stage of the use of BIM in Colombia and also in Argentina. That is something that I can, at least we realize during the strategy of use of BIM in Latin America in 2023. If we want to know more about this use of BIM, you can see here in this map different ways that you can approach for entities or associations that promote the BIM in different countries. For example, in case of Chile, Plan BIM is one of the most important, and this year is the last year for the set of BIM in the different structures. But also you can follow in the different countries of South America or in general in Latin America. So move it about of that and why it's important beam, and maybe that it's something that we need to connect with the technology, the use of digitalization, and you can see here the goals. The goals is improve the quality and efficient, increasing industry productivity, saving and reduction of inefficiencies in the life cycle. That is very important. Life cycle means that design, construction, and operation. So it's something that we are talking about right now. We are not focused just in construction. If you are in the field of construction, you have to see what happened in design, and also you have to know what happened during operation. And that is BIM. Transparency in information and project traceability, fundamental for construction, promote collaborative industry, provide better tools for participation, and predictable in execution times and cost control. All of that really, really apply for construction. So BIM is something that a methodology that move us, in that direction. And here you can see what happened in BIM in Chile in 2016. And look at this. So in the case of a construction, that it's important for us, of course. So you can see that the regular use of the BIM, it was not so how I can say, we prefer to improve and be much more regular and frequent the use of BIM in construction. And if you look at what happened with architecture or engineering, the percentage is higher. So, and that makes some reason of that, because technology, the collaboration in construction is something that needed to be put much more energy, because you have a crew, you have a lot of workers have to be coordinated and have to be teach them or training them in order that get all this information. Okay, and that is the reason why that it's the currently focus of BIM in the roadmap of the BIM in Chile, 2022-2025, is try to implement this in a better way in construction. So it means that the BIM environmental, the collaboration of technology, not only have to be in the design, in architecture, also have to be in construction. And you can see here some modeling that sometimes is very fancy, for example, for architecture point of view, or very useful in the structural model for engineering, but it sometimes is not really used for construction, and that is the challenge of that. And we have to move in that direction. So this is the life cycle of the use of BIM and digitalization. Of course, drawings, of course, structural models for design, local model design, yes. Probably then you have started to get some information from that model for construction. Then you have the program, the planning of that. Also, you have needed the cost and how we can implement that during the construction phase. But also the repair, what happened with the model of damage, what happened with the operation and the key KPI of this structure during the service life. That have to be BIM, and how we can understand for the use of technology. We don't need it just technology for technology. We need technology for a specific aim, a specific goal. And that is better productivity, better way that the understanding of the worker, the designer, the architecture, and even the users. So let me show some case of study, what we are researching right now in Chile about of building, about of transportation, to link, to match between this topic of collaboration using BIM methodology and digitalization, technology, equipment, and so on. So the first step is, okay, what is the most important challenge of this? The most important challenge is coming from this research. It's a research of one of my PhD students. He is Ali Bihendi from the New Zealand AUT, Auckland University Technology. And of course, in agreement with the Pontificia Universidad Católica de Valparaíso in Chile. And the focus is, if we want to move to the enterprise, to the construction companies, and provide digitalization and creates a transformation of that, we need to understand which kind of problem they have to implement the digitalization. That is the reason why this is focused in a human-centric approach for, in this case, Chilean case of study. And this is linked with a national project that it's called transference, it's knowledge and transfer of BIM technology for the Chilean companies in construction. And when we started to talk about of the human-centric digitalization, it's not like this, not yet, at least. No, we're not moving in the technology that provide the replacement of the human or the worker for robots. No, we are moving of how the digitalization in this image in the right side, how we can use it from the size of human, how we can incorporate all of the digitalization and technology in our work. So in that way, a short overview, right now we are moving from the first industrial revolution in the mechanization, I'm talking about of the 18th century, going to 19th century in the second industrial revolution in electrification, and then the third one in the mid of the 20th century with the automatization, with the digitalization in this century. And that is our scope. And that means we are talking about of industry 4.0 in construction industry. We are talking about of efficiency, and we are talking about of BIM, augmented reality or XR, 3D printing, IoT, cloud computing, and much and more and more. Yep. So how we can use that, how we can implement that. So it means implementation challenge, because I'm coming from Chile. Chile is not developed country. We have a limited budget. We have several problems to get this kind of technology and implement it in all of our companies. It's not something that it's probably that can happen in the first world, Europe, US, probably. But in our country, we have to understand how we can implement in a cheap way, in an intelligent way, in a smart way, you know. So in this case, I can say, for example, failures. 16% of successful implementation and 4% of successful implementation of this digitalization transformation. And this is coming from a survey. It is not easy to implement as a best practice. All the concepts that have to be included, waste of money. Look at that, 900 billion wasted in the 2019. What happened with another important thing, fear of being replaced? As I mentioned, no, what happened with, in our case, the engineer, the workers of construction, we will move, we will have to be replaced by robotic digitalization or not, we will provide a new skill that have to be provide in the sequence of construction. Probably that is the right direction. And finally, organization challenge. So our company have a lack of a skill and how we can improve that. And that it means a very nice schema of the Lang et al. 2022 about of Industry 5.0. Okay, so you can see here how we are moving from the knowledge empowerment from one side, move it from the essence, performance, cognition, theory, and from the other side, the value driven, coming from all encompassing transformation, evolution, and sublation. So that is when we're talking about of digitalization, but there are many words here, many concepts that we have to analyze, of course, and the idea is simplify that. And if we try to move in that direction, the state of art is something that you have to know. Yeah, for example, the different way that we consider our society, socio-creacy, the human-centered organization, and the human-centered design and humanistic management. I can provide here several references And of course, you can move it in deep in that way. So the need of a new approach means that we have to make a change in the way that normally we use and provide the service of construction, and understanding that that will happen. And the change means change management, how we manage that change inside of my construction. The leadership is moving, is changing, is challenging the leadership, and comprehensive guide for construction organization leaders. And that is something that we are focused right now in Chile and New Zealand in this collaboration in order to provide guidelines for all the companies. And we are moving in the way that the organization change management have at least these three or branches, no? The current state to a desired future state, the most suitable change model, which one is that? The change management model, which one we are using or we can recommend it, and the similarities and difference. Yeah, and that is the support of the leadership in this change management. So which kind of part of research or findings we are getting right now? Look at this. And please consider for Africa or for your country if you are in this same problem or challenge. This is the challenge in New Zealand, Australia, and the UK. The first one is resistance to change. So the construction company and look at digitalization and say, it's a problem for us because we don't want that, or means resistance to change. But the other problem is cost of investment. As I mentioned, the budget, and that is something that also happened in our countries, and lack of digitalization skills. And that is one of the important things that you are doing. And thank you for this opportunity for you and all your team, because it's part of these webinars and activity to improve the digital skills. But this is New Zealand, Australia, and the UK. But what happened in Chile? Chile is quite the same. Resources constrained, budgets, technical skill gap, the same, resistant to change. So it's the same, but in a different way. And this is an information that it's coming from many of traditional construction Chilean companies, and not international Chilean ones. Okay, so we are implemented this in a specific framework in Chile, and we say, okay, all of this knowledge, all of this theory, we have to be implemented in a company, small or medium-sized company. So we using national fundings for this research, we focus in 11 companies in the region of Valparaiso, and we implemented the following work methodology. First, a survey and leveling is a kind of selection of case of study, selection the challenge of the specific company of construction in order to understand how we can implement digitalization, how we can implement any kind of technology that provide and improve of the efficiency or during construction stage, times, or cost. Also, the second stage is office work. It means a preparation of the pilot plan, and finally the field work. And what is that? Go to the in situ, going to the work site and implement the technology. And that was very, very nice. So the roadmap for your site, if you want to follow this, is identify a possible case of study, think about of your companies, thinking about of your jobs, and say, okay, which kind of possibility of use this problem in construction to implement technology? That is the first step. Identify. Prioritize the use case based of importance. Sometimes you have a small things but have a huge impact, for example in the planning or the time or the cost. Okay, that is the right case of study. And finally, develop. Propose a structure to connect BIM and technology, and of course with the main target of the company for the optimization. So that we did it in that process. So we coordinate a pilot plan that include a traditional inspection using photograph, video, and records for identification of the problem, gathering information from the interviews with the worker, with the owners, with the client, the stakeholders. And after that, implementation of technology, use of drone, virtual reality, instrumentation, sensoring, vibration sensor, inclinometers, and according, so case by case. And after that, we move it for the BIM methodology to, try to use all of this technology in a right way. Okay, and let me show you. This is building two cases at least to understand. This is Paso Hondo, Quilpué. Is a city close to Valparaiso, the main port of Chile. And in that case, you can see here, this is the owner, the structural engineer in the left side, and it's a condominium. It's a buildings for houses condominium, and a prefabricated process of construction. So after understand that they use it BIM for the modeling, 3D modeling, they use it this during the construction. We implemented a detailed LOD 500 in a way to recommend to improve not only the design and architecture point of view of the use of BIM. So move it there and go to the construction stage. So all the work in terms of critical road and execution times, it was part of the important issue here. Which other important technology that we implemented? Construction and topography survey using drone. That will also be included in that, and also the implementation of mixed reality. And that is part, of course, for not for directly in construction, also for the sale or post-sale. I mean, how they can show the result of this construction process to the final client. Well, which kind of technology it was used here? Precast. So you can see here the walls of the buildings precasted. So we get that information, and then we put it in the virtual reality to show how that can be constructed, the construction sequence. And also we use it in instrumentation here in the photograph of the right. You can see the use of inclinometer, accelerometer, and temperature sensor. And why? This is the parking zone of the house, and this wall in the right side is exposed for the humidity in front first part, but also here in Chile we have a huge, very strong earthquake, and this wall, it was the highest vulnerability condition. So we used this in order to improve the operation assessment, and also provide some recommendation for the final client, for the user of the house. Yeah, and here you can see the different graph that can be implemented. This is also included, or could be included, not in this case, but it could be included in a domotic way. It means it could be information that can you provide for the user, or for the construction management or operation management. Here you can see the virtual reality. So in the left and top image, you can see the precast wall. After that, here you can see the 3D model, the same wall, but now in the right position in the parking zone of the house, and also included a specification for example, the girders or the anchorage that is needed for the construction. And in the right photograph, you can see a gamification. It's a virtual reality provide the identification of critical elements, and we use it for a worker training. So you can use this virtual reality with the worker in order to they understand which kind of element have to be located in the structure. So that was very useful, and probably is something that for the new worker be considered for that stage. This is another project for building. It's a single family home, a residential house in Peña Blanca, another city very close here to the port of Valparaiso. And in this case, the construction team, they never use beam. They never use any kind of technology. They work in the old times. It's so the way that we can improve the use of technology for them, it was of course the survey, analyze the problem that they have during construction, and we recommended to use a tablet type mobile device with included the BIM file, BIM viewer, with a LOD 300 level for that. And also we use sensors. We use sensors in a specific wall because during construction they modify the drawings, modify the topography, and in a specific zone of the wall that not consider a cliff, not consider a cliff zone, it was changed for a cliff zone. And unfortunately, the construction of that wall that was not modified, the design and that was not modified for limit of budget, and limitation of budget. And that was one of the solutions that we say, okay, we can use inclinometers in order to make some kind of warning or alert for potential problem of out of plane that could affect this structural element. Okay, so you can see here, this is the wall, one of the pier, or the column of the wall. We are using this sensor of inclinometer, and we using a specific three-hole to analyze if the inclination of that it could be affected and produce some risky condition. And we use also temperature sensor in order to analyze if the environmental condition could affect it also the result of the inclination data. We also use the virtual reality, but in this case that was not used really for construction stage. It's much more focused in try to resolve the interference model. I mean, for example, electrical model or piping model, and show all of that specific detail to the customer, for the final client. So the next stage, and that will be during this year, it's absorption. This year we will follow with this project, and we will try to provide much more information to this company, give them and provide new technology. For example, in this case, we are using this kind of integrated sensor. Of course, we are using BIM modeler software. In this case, we are using Allplan. It's very, very nice and comprehensive software for use BIM Plus for operation and also for drawings. Drone with RTK workstation. This is like a bar in the soccer, but in this case, it's a workstation for during construction. Just to check the drawings, just to check the 3D model of BIM, of course, tablet and augmented reality. All of that will be implemented during this year. So if we have the chance to talk about this next year, probably we can show the result of this research. Okay, that is my first step or stage of my presentation, and right now I want to move in the minutes that I have left to the infrastructure. Okay, what happened with the infrastructure, transportation infrastructure in Chile, and of course also in my collaboration in overseas. So I want to start to focus in railway bridges here in Chile. We have here in Chile 355 bridges in the inventory, in the cadastre, and here you can see in specific ones, some cases, for example, Aconcagua Bridge, Cautín, Mayeco, Tolten. All of these bridges is a truss metallic steel bridge rivet. And you can see the dates of in service in 1889, 1916. So very, very old bridges. And that produced that the pathologies is something that is very uh, it's a concern for us. It's a problem really for us. You know, corrosion, concrete damage, cracking. Yeah. So what happened in the case of from our side construction, if we are talking about of this, all bridges, all structures, how we can uh, provide our support from the side of construction. Of course, is from the rehabilitation, strengthening, repair project. In that case, the construction also be part in the life cycle, in this case of the operation. So understanding that and following with our ideas of how we can implement technology and digitalization in this kind of problem, we awarded another funding project. It's called Fondef IDEA 2024 Bridge Damage Monitoring and Prevention System based on prediction model generated by artificial intelligence. And okay, my acknowledge for the team, the director here, Ricardo Soto. He is informatic engineer. Also Alvaro Peña. He is from the side of mechanical soil. Well, you can see here me. I'm a researcher of bridge and sensors and all the stuff. And we have three PhD students, Jose, Marcelo, and Juniel. He is supporting all of this research. So I acknowledge all of the team. And when we started with this project, we talk about okay, which are the research lines. So we focus in three clustering. The first clustering is artificial intelligence and data analysis. That is, of course, leading by our team of informatics. Yeah, early detection of anomalies, prediction of structural problems, and maintenance optimization. But the second one is the second cluster is Internet of Things. So how we consider the data acquisition, continuous and real-time monitoring, which kind of sensor we are using, the efficient of data communication, advanced data storage and management. Okay, that is another focus that we analyze in this research project. And finally, the cluster of digital transformation. So improve decision making, maintenance efficient, resource optimization, extending service life. So here we are much close with the owner, with the professional that involved in the digital transformation. So for that, we are moving in the regulation and codes. In Chile, we are very close with the American code. So American Railway Engineering and Maintenance of Way Association, AREMA, is something that we are used. Also ASHTO for bridges, Manual de Carreteras and REDEFE, there are a national code for that. So if we want to try to implement technology, the first step is, of course, tech specification. And here is the preliminary analysis that we did for this research project. We are considering inclinometer, sensor triaxial, gateway, of course, displacement sensors, rain gauge, CCTV, and accelerometers. Of course, that is the preliminary analysis. Right now, we are already and implemented just the accelerometer. And that is something important for Chile because one of the main issue here is the earthquake, and the bridge that we are using as for the case of study suffer a settlement due to earthquake solicitation. So, but when you want to provide a right digitalization using sensor technology, you not only say, okay, I want to use accelerometer, so use this specific accelerometer. No. You also need to understand and link the sensor, the technology with the KPI, the key performance indicator that do you want to measure. So, for example, in the case of accelerometer for our project is to analyze what happened with the soil acceleration, the mechanical soil acceleration, and also to understand the different mode of failure that can be occur in this bridge. So this is really important recommendation. If you use technology, always you have to identify the KPI and the target that we'll use. This is an example of the location. Of course, this is not specific for this project. It was a road bridge project that we implemented in the south of Chile. And of course, BRIM, in this case BRIM, because it's Bridge Information Model, is something that have to be considered in this project of research, as I will show you in this next slide. And this is the flow chart of the use of technology using the artificial intelligence for the forecast. So the sensors, the data go to the gateway data go to the cloud service go to the algorithm of intelligent artificial intelligence, and then we have the prediction of that. So that is the schema that we are using. Of course, the cloud service, it's two branch. One branch is the APP mobile online analysis, and online, of course, could be offline. In the case of bridges, is something that is important because sometimes the bridge is out of the cities, out of any kind of civilization, is in the countryside, and you don't have any kind of internet connection. So offline is always a very good option. And website is also be included in the analysis. So following this research project, we are implemented this in a digital twins, BIM, and XR visualization in Las Cucharas Railway Bridge in Viña del Mar. Beautiful place here. It's a touristic city, a beach area, very beautiful here in Chile. So please take note of that, and in case that you can visit us sometime. The bridge is a truss bridge, riveted, as I showed you previously. This is a photo of, I suppose, during the last year. It's a railway, maybe it's a metro, is the right way that we can give the typology. Here you can see the survey visit use it for the digital twin. So of course we need to go there to understand what happened with the different elements. So in this case, the bridge is considered a viaduct of an arch bridge. You can see here in this photograph, and a truss bridge is the main part, the main span of that. So here you can see our inspection in the railway area, in the bearing zone, and also close to the river. We use a drone for the digitalization, DJI Phantom 4 RTK with a high target B30 plus and controller and Trimble for the scanning. And here you can see the preliminary result of that. So also we have a visit for the sensor location definition here with a colleague from the UPC in Barcelona Tech, Spain. And here you can see the gamification of this one is provide the virtual reality for the training of the inspectors. We use Oculus Quest 3 and HoloLens 2. And we use a creation of digital twin with the first model using a photogrammetric survey, Metashape, Blender, and Unity. This is the second analysis, and the third one also with the topography. And this is really important for us, for example, for climate change, to analyze any kind of potential problems coming from the river, from the scour, for erosion, fires, or landslide, for example. So you can see here this. And the interaction with the digital twin is also, we create a road for inspection and also give a specific training for the inspector with information of the drawing, information how they can take photos, information how they can be safe during the inspection, for example, if the train is coming, and so on. So here you can see on a specific location of the bridge. Also, it's an avatar. It's look like me because they used my face for doing that. And okay, talk about of the different stage of the training. Yeah. So let me check if we have time for a short video of that. Let me show you the project in a few minutes. Okay, Blas Cucharas Bridge. This is the metro wagon that is crossing the bridge. You can see different color because also it's a very old bridge, so there are some problems, specific damage that it's showing in and pop up during the inspection. It's very interesting, this bridge, because it's overpass in the highway, but also it's over the river. It's also over a local road. This part that is showing, this one, the abutment, one of the abutment have some problems, and that was strengthening during the first decade of the 21st century. So here you can see the model, the general model. So we try to identify also the environment in the conditions of the forest, the river, the even the use of the bridge, as you can see there. We used this kind of icon to interact with with the inspectors preparing before. Look at this. That was, of course, in Spanish, and I want to say that it's shown a specific location, the drawing, and what he said that a specific way that they can approach and make the inspection of this element. So that is the way that we are using the training. It's also included information about of what you can see and how you can follow with the inspection. So you can see here, I will move a little bit faster just for time. And you have different areas for doing that. Let me continue from this side. So it's important also the different location, and that was the information that had to be provided during the training, and also the ways, the road that the inspectors can use this virtual reality is a freeway, or also you can move from the a specific shore and then move to the other shore, to the opposite shore, or if you want, you can go upstairs, go up to the bridge. Look at this. This is go up to the bridge. So then you go to this platform, and then you move to that position. Okay, that's it. So, oh, sorry. Just I want to. Okay, I think that I have just 5 minutes more. So I want to show you the last part of my presentation. I'm sorry for a little bit of the delay, but I want to talk about something that it's important. That it's how the company can be make the digitalization and work in a global way. And Equibridges is, I show you this because Equibridges is a company enterprise that from the beginning, from the 2020, they decide to make all the project in a digital way, and make the design of new bridges, bridge preservation, and bridge assessment but all in the digital way. And that is the reason why Equibridges decide to make an international collaboration. So several of the team is located in many places around the world. For example, in my case in Chile, or for example, in case of Africa, in Africa, in Zambia, Ernest Kakoma, he's a master's degree engineer and all plan modeler. He's part of the Equibridges, and but he's working from there. Even more, that provide this kind of flexibility, gives the opportunity to contribute in a different project using the research. In my case, the research coming from the university in Chile. In the case of Africa with Ernest, he is involved right now in the research in the field of structural fire engineering in the Stellenbosch University in South Africa, for example. So it's quite the same. It happened with Uruguay, with Luciana, or Laurent in Madrid, Spain, of course, Switzerland, and so on. So this is the team that provide all of this digital or international support. And I want to show this because let me explain how an enterprise can be or can provide digital service. First of all, for example, design of bridge, conceptual to design, to execution, design and structural analysis as a sub-consultant also have a specific template. So a specific template, it was done in Chile or in Switzerland or in Zambia, is follow the same protocols and in the same template. So as you can see here, no? Prof checking, quite the same. So prof checking, the reviewing of drawing is something that it's important. So all the platform is available in South America, in Europe, and in Africa to analyze in a collaborative way for example, the proof checking or the review of the drawings. Also give some support for the codes and guidelines, and that is really interesting because Equibridges, for example, inside of the cloud, it's considered the e-library. It means that we have all the storage of information, codes, and guidelines open for all of our collaborators. And that provide the possibility to give some support from owner, from ministries, or from municipalities, because we have a very huge library, e-library. The research, as I mentioned, and development, interesting or important things that is working, we are working right now. It's, for example, in the side of construction, the use of ultra-high performance concrete that was used for rehabilitation, repair, or, for example, the monitoring of performance that also be part of our research and development. But one of maybe most important areas is BIM, yeah, digitalization of archive information. But it means not just scan the information; it's try to include the information in the BIM model. Okay, so that means that if we have a BIM model, a 3D model, and we have a specific element, for example, the reinforcement here, you can click there and you can get all the information of the technical information, even if the bridge is old. For example, no drawings or no comprehensive information. So the idea is try to complete that information, research about of that, and then implement in a standard way. Also, the beam to film. This is really important. Beam to film is a very nice concept that is construction without drawings. I mean, construction no using drawings in paper drawings. We use the tablet, we use the working station, and that means that the worker have to be a challenge, a new challenge that it's understand and know how to can use this digital drawing or digital 3D model information. Yep. And another important issue is the BIM models for operation space. As I mentioned, we are talking about life cycle, not only construction, not only design, also operation, and we are supporting on that. And that means bridge assessment management in the case of equibridges, because we are focused on bridges. But if you have, for example, a condominium, you have building, family buildings, or I don't know, another structure, of course, you can use this active assessment, building assessment management, or industrial structure assessment management. And of course, the interface between bridge owner and transport company, for example, using IoT or using, for example, technology for identify, for example, heavy transport or heavy trucks or oversized trucks that could be a problem in the network, road network, for example. And we are focused on that bridge design with short courses. And in Zambia, in Lusaka, in 2023, that was our first activity. 2024 was in Japan, in University of Kanazawa. And at the beginning of this year, in January, we have this Plan and digitalization courses in our university here, in Catholic University of Valparaiso, and we are open, of course, in other places. Plan is our software. We use the expertise of this model for bridges, focusing bridges, 3D design of reinforcement layout, beam models, and representation of that. And we use common data environment and CDE for the projects. And for design, Sophistic is our main software for design, and we try to link it with beam construction model. We use Sophistic specifically because it's a very nice software for construction stage analysis, and that provides support also during construction. So just to finish, I want to show you just one or two examples of the use of this knowledge of the equibridges in a real project. Okay, this is a 2 Swiss beam pilot project for existing bridges. We using rehabilitation of historical bridge through UHPC, this ultra high performance concrete. And the most important issue is that we use digital planning workflow and beam to fill. Okay, so the first one is Maillard Brücke Arburg. It's a rehabilitation bridge. This is the bridge here. And we provide the rehabilitation of the bridge deck using this ultra high performance, but we use fiber reinforced concrete. That was the first beam project for rehabilitation that include beam to fill. And the idea was they use the beam model compatible with the bridge assessment management database, the bridge management system, with a special focus in the rehabilitation, also in the new drainage system, because there was some problem of waterproofing. So some photograph from this bridge since the first one in 1837, the replacement of 1969, and the rehabilitation in 1996. So after that, this is the bridge, 1996, the rehabilitation that was during this in 21st century. So the initial situation, it was a missing waterproofing, transversal pre-stressing, and chloride that was identified. So lack of structural resistance of the sidewalk in this area and this area for the pedestrian. And this is the drawing, the blueprints, if you want. Not really so much information, and also needed to analyze what happened with the drainage, because you can see here that the drainage, all the waters go directly to the main girder. So we analyze in a traditional way for what happened in the condition, and we identify the leaking expansion joints. This is the drawing, this is the expansion joint, and corrosion in the abutment chambers. Here you can see that. So two huge problems. And the other problem is that the access of the abutment, it was not really nice. So you have to go inside of and analyze the abutment, but you go through in the center of the roadway. So that makes some disturbing traffic for analyze that. It means that provides special condition, high amount of heavy traffic, narrow roadway, difficult to cross. So that means that we have to prepare a comprehensive plan for construction, in this case, rehabilitation project. So the project scope finally go to the waterproofing and structuring of the deck, reconstruction of the bridge decks, and combined cycle and pedestrian lane. And you can see starting to see the deck rehabilitation, the waterproofing and structuring using a UHPC layer. And here you can see the 3D model of the bridge that was carried out by us, by the Equibridges, and also that provide also the drawings. We use the part of the research of the UHPZ, in this case cement with a matrix with 3% of fibers, a strength of 200 megapascal. That is not really so important in this case. It's much more important the 15 megapascal in tensile. And it's important to understand that under 7 megapascal is the waterproofing is excellent using this material. Very durable, high density, low porosity. So that was the reason we use it in this case. This is the application of that. So this is the existing element, and the UHPFRC here, removal 2 centimeters of existing concrete, and then after that, using a moistening of the surface and placement, the reinforcement and puring of the UPC HPC. For that, they needed to adjustment of abutment, so we eliminated the expansion joints, and we make a connection with abutment. It's a semi-integral bridge, and you can see here in the model that we included that is as a new structure. Look at this. This is the model. It's easy to understanding the way that we connected the abutment with the structure. Also, we use this approach slab for reduce the settle of the approach road of the bridge. Also, the elimination of bearing and the specific detail of reinforcement. This is quite easy for, in my point of view, for the constructor, for the worker, to understand how we can implement the different reinforcement, the rebar, you know. And also we'll provide a laser scanning with a point cloud of laser scan. This is one of the first analyses, and the reason why is because we did not really have the drawings, original drawings. Also, in the beam model, we use a drainage model, including initial stage, construction stage, and end stage. Here in the right side, you can see the drainage model. And that drainage model is also included in the geometrical model of the bridge. Also, in the methodology for the beam models, we use a 3D visualization. And the 3D visualization, for example, if we clicking the specific element, so you can get all the information. For example, the volume of this element, the height of the element, the longitude, the length, sorry, of the element, which kind of code is used for the specification of design or construction, and so on. And here in the left side, you can see the software that is used for the management of this bridge. I mean, it's like the name of this software is Incuba. And what we did, we linked the data for BIM with the data of the management system, the BMS. So that is the use of this. Predefined view is also used. So for example, if we want to show for the worker a specific detail of the rebar of the UHPC, okay, we predefine this view, and if they go to the workstation or using the tablet or BIM viewer, they can see a specific view that from our side, from the side of constructors, engineer, construction engineer, or civil engineer want to they understand. Also, we use in GPS point list, pyramid point, like this is a pyramid point, and that provide that all the reference is in the right way, and also provide a very easy way to report in the model any kind of change of that control. All of that methodology it's providing in an automatically generated information with a reinforcement list, with a bill of quantities, submodel of information exchange, for example, formwork, construction program as a property, inspection and control plan, and so on. Fortune, I'm not sure if I think that my time is end. I don't know if I have 2 or 3 minutes more for talk something more, or just let me know.
Okay, 3 minutes more, Prof.
Okay, just to finish this. So thank you, Fortune. This is another project, the bridge Dufour-Strasse. It's close to Zurich. It's a urban bridge, and this is the impressions, the first condition. And you can see a lot of damage problems, humidity, waterproofing is not right in the right way. So in this case, the process for the preservation project is considered a preparation of basic data, design, and of course execution, and after that, how we can link it with the assessment. So in this case, we provide a BIM model, and this is not easy structure because it's considered a gallery with a bridge, with 2 bridges, and in a urban as a urban structure, there are a lot of non-structural elements. So you can see that the nice things here is that you can use this and understand the different, from the different point of view, all the elements that have to be considered. So using Altplan BIM Plus, it's also very nice to understand and move in a different way the structure. So you can see in a transparency different levels of the gallery or the bridge, and give a very nice way to understand all the structure. So you can see this use of BIM Plus. So of course, the client provides some client specification. We use in that specification for that, and with that specification, we create the BIM model for assessment management using different models: geometry and basic attribute, damage model, condition assessment, structural analysis, and measure and recommendation. For example, for damage model, so you can see here in different color the data. For example, if there are problem of corrosion, there are problem of cracking, so you have different color. For example, in the case of corrosion or waterproofing problem, you have the color blue, and so on. In that way, it's quite easy to understand. So this is normally that we consider for detect damage and show in a drawing. So if you compare that with a 3D model, of course, 3D model could be much more easy. It's easier than the other way. So condition assessment, quite the same here. You have the frequency of damage in a different slabs. And also you can include it. This is in a research process right now, structural analysis included in the model. So for example, in this case, you have a transverse beam, but that transverse beam, it's linked in a simple supported analysis with the main girder. Yeah. Okay. And this is a measure of recommendation. Of course, after that you finish the design and in preparing for the execution of the construction, you provide this model to define, for example, red color is that you needed to waterproofing protection, or if in the case of green color is, for example, if you needed to, I don't know, reduce the corrosion or so on. So final thoughts about all of this. First of all, BIM for assessment management of complex infrastructure is something that I think that is really, really important. Secondly, We are from the side of construction, but right now digitalization is interdisciplinary. We needed a lot of colleagues coming from different areas. If we are using BIM and digitalization is probably the no information loss. So that is important things. And the future technologies, future and present could be is LIDAR, 3D scanner, augmented reality, virtual reality, and of course sensor and instrumentation. So that was my presentation. Thank you very much. My name again, Matias Valenzuela, and there you can see my emails, matias.valenzuela@pusb.cl. Any kind of research do you need it if that is my home, the university, and of course Equibridges in the if you need any kind of support in a specific technical design construction. Okay. Thank you very much again, and I'm open for your question.
Thank you so much, Prof, for that very, very thought-provoking presentation. It was really, really eye-opening for me to see what you guys have been doing over there. Thank you so, so much. I want to, we appreciate those who are listening to this presentation from Liberia, from South Africa, from Nigeria. Do we have any other country apart from these three countries that are here? Just signify if we have more than three of them here. But if not, we would like to open the floor for any question for Prof. If you have question for Prof, please just turn on your mic. Thank you so much. Huda, please.
Thank you very much, Prof. It was very, very nice to know this information. I have two questions. My first question is how any part of engineering, like civil, electrical, and so on, can be fit on this equal bridge. My second question is it easier to start building the bridge from scratch or to fix, because now I noticed that all of it is fixing the weakness in the historical bridge. Sure, we cannot destroy them because they have a historical meaning. Is it easier to start it from scratch, or it is easier to fix those weaknesses? And also, is there any sensor that can be a sensor for the earthquake? Because Chile, for example, it has too many earthquakes happened, and other climate exchange and or problems. Thank you very much.
Yeah, thank you, Hilda, for your question. I will try to understand. If I understand well, please, if in case that I know, please let me know. If you talk about electrical, the electrical engineering in the case of bridges, also in the case of building, and we realized during our survey and of course in the pilot project that the main issue here is the electrical engineering, the electrical project. In the case of building, maybe it's worse because in the case of Chile, normally the architectural point of view and the structural models is always very well coordinated. But after that, during construction, normally the electrical engineering project is developed during the construction stage. And they finally provide for the constructor just the plug in and plug out without any kind of road from the cables, for example, or for a specific way that they can give us the importance of this cable for the electrical project. What happened with that? It's that during construction, normally we finish for example, the main girders, the slab is everything is done, and after that, the project, the electrical worker arrived to the house, sorry, or the buildings, and started to drilling all the elements, the structural elements, and that happened. So one of the most important things that we are trying to push using the BIM and also the digitalization is to invite the electrical team to be part of from the beginning of the project in order that they can give the right specification of that. Okay, from the side of the bridges, the electrical, it's not really so much important. One exception is the long span bridges, or this we call it singular bridges. I mean, for example, cable stay bridges, suspension bridges, that, for example, they use it dehumidification system, for example, or emergency light. Well, that it's another story, and of course, the electrical project had to be, as I mentioned, for the buildings in the beginning of the stage of design, and of course the stage of construction. That was the first. I'm not sure if I can answer in the right way for you, Hilda. Yeah, right.
I'm sorry.
That was your first question, right? But your second question
This
was.
my first question is about collaboration. Now you show us that it's the collaboration between the too many parts of the engineer in this project.
Yeah, yeah. The calibration, the collaboration is something that is very, very hot. So we are working right now. Is we are going to the owner of the project, and when we arrive with the owner of the project, we recommend them that try to use the same software, the same platform, the same digitalization way for all the companies that will be involved during construction and even during architecture and the designer. Otherwise, it could not be useful for reduce the interference during construction. So we have one problem. We detected one problem for example, in industry structure here in Valparaiso. And what happened? The owner decided to hire two companies. One company is a constructor company, and in the same level, the electrical company of construction project. So in that way, nobody control the coordination of both companies during the process, and that was produce a lot of interference and a lot of problems. So our recommendation is that try to use the same software, the same digitalization platform, and beginning a kickoff meeting with all the companies that have the same protocols for that, using, of course, the BIM methodology. And I'm sorry,
My
Hilda.
second question.
Yeah, please.
My second question was: is it easier to start the bridge from scratch, or just to fix the weakness in this bridge? And also, are you use sensors for earthquake and climate issues?
Yeah. Well, if we consider that a life cycle design, it could be absolutely better if we consider from the size of design, all the stage of construction and all of the stage of operation. And in that case, you can reduce the damage, and you can reduce any kind of problem or interference during construction stage. For example, in one of my projects, during the design, when we finish the design, all of that information we provide to the constructor company and maintenance company. And they give us some requests of modification of the design, not for the design safety, it was for example, reduce the interference and also to reduce the maintenance costs on operation. So that is one side. And if we are included, for example, technology, I'm not talking about of BIM, I'm talking about of sensor, it's absolutely nice if you consider from the early stage of your project. I mean, for example, in the case of earthquake, in Chile, in our project, but not in all of projects, but in the case of large bridge, for example, the sensor, the instrumentation project is included from the design. I mean that, for example, accelerometers, strong motion accelerometers, it's included in order to analyze what happened with the acceleration of the soil around the bridge. And it's probably that also be included during the construction, the installation of the accelerometers for the deck, for example, or inclinometers in the piers, on the pier. So I recommend, yes, I recommend that the instrumentation and sensoring could be part of the construction project. But if you are considered that responsibility could have to be not only for a general constructor, have to be give to a specific or specialized in instrumentation and sensoring.
Thank you very
Yeah.
much. Thank you.
Yeah, thank you. Thank you for your question, Hilda.
Thank you, Prof. Before I call on Engineer Womoti, I got somebody sent me a question to ask. You talked about collaboration, and somebody asked how can they also be a collaborator.
Sorry, I'm not follow you. It's how we can collaborate. You mean in general, or how we can collaborate between South America and your side? I'm sorry, not follow about that.
Yeah, somebody sent me a question saying how can they also be one of your collaborators? Like you mentioned somebody from Zambia, just like that.
Oh, okay. Yeah. Of course. So we have this idea to be very open. In my case, for example, following Equibridges, in the case of in the case of Africa, Ernest could be our the person, the professional could be the link with all of you. But if you want, I show my email. So please feel free to send me an email or using LinkedIn, as you say me, Fortune, and absolutely open to start collaboration from the size of the university, research project, even as I mentioned with the consultant companies. So we are open of that, of course. Sure. Send me an email and I will answer as soon as possible.
Okay. Okay, thank you so much, Prof. I guess everyone's heard that, so you can collaborate. So I call on Engineer Womoti for his question. Then we move to QS Kotsani. Engineer Womoti. Okay, QS Kotsani, please.
Thank you, Prof, for this wonderful presentation. It was very insightful. I actually was curious because you did mention that the software, it uses Internet of Things and no information is lost when you use the software. And you can use this for design review. And I think that is very critical during the early stages, like at feasibility stage, and also when you do plan maintenance. So I just wanted to find out, since it uses AI, is there a way of, like when you do inspections or when you,
Hello.
oh, sorry about that. Oh, so when someone does inspections, on at the field, and also when maybe when you're designing using that software, is there a way of it? I don't know. Maybe it could be a future feature that it does. But I don't know if it does that. That if it can assist on giving the accurate calculations for it to for whatever bridge or structural design from it collapsing. Can it suggest, you know, the best practice for, you know, an engineer to do, you know, to provide recommendation on how to fix an existing structure?
No, really nice your question, Kusani. I appreciate that. And as you mentioned, is I think that it's something that we have started to analyze that. Let me say something. The artificial intelligence right now, it's something that we have to explore and we have to use in the right way. And yes, of course, I think that artificial intelligence, it could be very useful in the case of missing information, in order to forecasting, you know, and provide the better judge of what happened with the structure. Let me say two or three thoughts that I have about that. For example, we are starting in my university with a project of the how we can use artificial intelligence in the case of collapse of dam. Not bridges, not buildings. I'm not the main research about in that case, but I'm linked with them. And they are using image coming from the open source. I mean, for example, Google Maps or Google Earth, sorry. And after that, they identify the dam and request to the artificial intelligence to analyze the potential problem that can be detected in that. And then when move it in that direction, you can provide another information. I mean, for example, photograph that you can have, or you can give some vectors, the keyword vectors, to the artificial intelligence, and then go in deep in the analysis. So we are preparing right now a national funding project about of that, but in bridges. Right now, I mean, it's an ongoing project right now, preparing the project. So my idea is to use it that and probably calibrate it first with bridges that we have comprehensive analysis of damage, for example, or bridges that collapse, or bridges that could be out of service right now, and try to training the artificial intelligence following the methodology that I mentioned to you right now, in order to analyze if it could be a good assistance for that. But I'm can say more than that. We are preparing the project, the proposal of the project, and of course, if you are interested in that line of research, please let me know, and maybe we can collaborate.
Yeah, that is very interesting. No, thank you, Prof. Yeah, because I've noticed when it comes to existing structures, it's sometimes the engineers do multiple investigations. If it's water damage, it's hard to find where the leak, you know, the leak is and all that, and what could be the issue, for example. Yeah.
Well, the forensic engineer is something that it's is one of my passion too, because as you know, it's one thing is the symptom. You know what is you can see after the collapse, or even in the case of huge damage. But the important thing sometimes is the root of that damage. You know, and maybe it's another good way to use the artificial intelligence in order to provide at least a good guess of hypothesis and assist you in that way. But it's something that I think that we have to analyze further before to say something about that. Sure.
Okay. Thank you.
Hello.
Thank you so much, Prof, for that. Please,
Okay, hello. Can you hear me?
Engineer Moti, please take the floor.
Yes, Prof. Thank you very much for a very beautiful presentation. Because you're able to cover green, brownfield projects and even asset management, which was very, very interesting. Now, earlier on, you talked about the challenges, that industry is having with respect to adopting digital technologies, especially in the construction industry. So I want to ask, can you advise how, and I think most of the construction organizations, the most pertinent variable is finance, the cost of adopting some of these technologies is huge. So what do you recommend? What do you think especially in Africa, developing contractors and organizations, how can they surpass financial issues in order to adopt these technologies? Thank you very much.
Yeah, I think that it's would. Oh, I'm sorry. Okay, that it's too much for me. Yeah, it's one of the main issues that we are researching right now. It's as I show you that the different reasons why the companies not implement the technology. And sometimes, let me say something, sometimes they implement it, but not in the right way. And that produce that it's implemented in a short time and they not receive the right results. The problem here is not technology. The problem here is, this is my thoughts about this. The problem here is not necessarily the technology. So you can get fundings and you can, implement your technology in your company and so on. Okay, this is one thing. From the other side, you have it's not really a problem. For example, for example the owners that for example they wanted to implement technology and they received that technology, they not have really a problem. So you provide the technology, the owner say, okay, please use that technology. I think that the problem is the real problem is how we can match between the needs of the owner and the solution that can provide the technology. And sometimes that match is not in the right way. So let me say it, for example, from the side of the professional that provide the technology, they want to use this technology, and maybe they can say you, okay, this sensor, this specific sensor, give you all the very accuracy in the data acquisition of the inclination or the displacement, one example. But really, that information is not useful for the owner, Okay, and because the owner have some problems of really much more linked with the construction stage and not of the behavior of that. So what we realized that finally the problem is really coming from the human center. So how we can implement the technology and make that the implementation can be used during a period of time and not be used only in the first shot. You know what I mean? Because we can put all the we have get all the permission of the owner, and we have the fundings for putting the technology in the construction. But finally, if the worker not use that technology, or if they use the technology, not provide the real improve in this user, and not provide a good result. So finally, the gap exists without that doubt. There another thing, and let me say that it's about of the culture. You mentioned what happened in Europe, in South America, and in Africa. From my point of view, I think that is very customized, this process. you have to customize this process, because the problems that we have in South America probably is different in Africa, and probably is different in Europe or in New Zealand. So you have to understand very well the environmental condition in your country or in your continent or in your culture, in order to define the best strategy to provide the digitalization in construction. And that is the reason why, from my point of view, that this is an opinion, okay? It's always important have national, professional, in any kind of international company that make or construct or design in a specific country. I mean, for example, if this company of Switzerland come to here to Chile, they come given all the high quality technology, but they needed the idiosyncrasy, they needed the understanding of the culture of the South America, and understanding the best way that they can provide this benefit of the design, construction, and operation in my country. You know what I mean? I'm not sure if that makes sense to you, what I say.
Yeah, sure. It's, yeah, of course it does. Yeah, yeah.
I mean, I mentioned something, that the resistance of change, the resistance of change, yes, it was one of the, we analyzed that one of the parameters or the variables that the digitalization is hard to be implemented. But if you go in deep in the concept of resistance of change, it's absolutely something that is coming from the human being of the culture. So if we put it resistance of change in Chile, in the survey of Chile, I'm absolutely I think that is it's absolutely different than the resistance of change in New Zealand. I mean, the factors that make that resistance happen are different. Yeah.
Thank you so much, Prof. It's been a wonderful time with you. You've so much enlightened us, and we are so grateful for this. Any other question before we call it a day on this? Okay, Ms. Kuzana.
Yes, Prof. My last question, you mentioned about that there's resistance of change and it differs from different locations, wherever you are. But what is the main driving factor of this resistance of change?
Yeah. Well, let me. I think that it's different in different culture. Let me respond from my side, from South America or Chile. Okay. So I think that the resistance of change in our companies here in Chile, it's coming from the feel insecurity of the worker. I mean, it's something that let me say a phrase that the workers say. I don't want to make any kind of change because what I am doing is working for me. So it means that you are request me make an effort, but why you say that if I doing this and it's working? Of course, they are not looking that the results, it could be optimized, of course. But there's something in that phrase, in that sentence, that they don't want make any kind of change. First, because it means it needed to put energy to change first, and secondly, it's probably that they say, I feel comfortable with this. I'm feel nice right now. It's working for me, for the worker, I mean. And so why I have to make the change? So that is one example. Of course, there are another, and probably um, it's something that is different from one specific worker or one specific area or culture, and that maybe change to other. We can make clusters, of course, and it's something that we are working on that with Ali, my PhD student from New Zealand, because there is analyzing Australia, New Zealand, and also South America. So probably after we finish the PhD thesis, we can give you more detail about that difference or the similarities. But I think that it's coming from that way, my response. Mm-hmm.
Well, thank you so much,
Okay.
Prof.
Yeah.
Okay. We want to thank you and appreciate you so much, Prof, for your time. Thank you for spending this over 1 hour with us. And we must say that we really, really enjoyed every bit of your presentation. And we hope that when we call you again, you will be there to you'll respond to us. So we appreciate you, Prof. And we just want to say to you, have a wonderful night rest if it's night in your side. And we hope to see you and collaborate with you in the nearest future.
Yeah, final words for you. Thank you again for your time, for your question. Absolutely insightful for me. That was beautiful. I appreciate this opportunity and absolutely open to continue talking, collaboration in the future. And I will keep your message and your comments. So thank you very much again and have a very nice night and evening.
Okay, thank you so much. So next month, we're bringing another guest to the webinar, and we want to thank you all for staying with us till this time. So from us here, we say to every one of us, good night and have a wonderful night rest. Bye.
Bye-bye.
Bye.
Bye.
Bye. Thank you all. Bye.
Thank you all. Bye-bye.